One man working alone in a patent office. No lab, no colleagues, no funding. And in a single year, he rewrote the laws of the universe. But the theory that made Albert Einstein the most famous scientist who ever lived, he spent the next decade doubting it, rebuilding it, and nearly losing his mind over it. And the strangest part, even after he finished it, almost nobody understood what he'd done. To understand why general relativity is so revolutionary, you need to know what came before it. In 1905, what historians call Einstein's miracle year, he was a 26-year-old nobody working as a technical assistant at the Swiss Patent Office. In that single year, he published 4 papers that would reshape physics forever. One of them introduced the special theory of relativity. It started with just 2 ideas. First, the laws of physics are the same for every observer moving at a constant speed. Second, and this is where it gets weird, the speed of light is always the same, no matter who is measuring it or how fast they're moving. That second one breaks everything. Imagine you are on a train moving at 50 miles per hour, and someone outside is watching you. You both look at a beam of light. Common sense says you'd measure it differently, but you don't. You both get the exact same number, always. To make that possible, Einstein had to throw out something Newton had assumed for centuries. That time is absolute, that it ticks the same for everyone, everywhere. Einstein said, no. And space and time aren't separate things. They're woven together into a single 4-dimensional fabric called space-time. That was special relativity, revolutionary. But Einstein knew it was incomplete. Special relativity had one giant blind spot, gravity. Newton's theory of gravity assumed that when the sun moves, the Earth feels it instantly faster than light. But special relativity says nothing travels faster than light, contradiction. So Einstein set out to fix it. Most physicists thought this was a straightforward engineering problem. Just patch gravity into the existing framework. But Einstein had a completely different intuition. He thought gravity was something far stranger, something no one had ever suspected. In 1907, Einstein had what he later called the happiest thought of my life. He imagined a person in a sealed elevator with no windows. They drop a ball. It falls. Now, are they sitting on Earth being pulled down by gravity, or are they in outer space with the elevator accelerating upward? There is no experiment they could do inside that elevator to tell the difference. That simple thought, that gravity and acceleration are the same thing, became the equivalence principle. And it cracked open an entirely new way of seeing the universe. If you can't tell the difference between gravity and acceleration, then gravity isn't really a force at all. It is not something pulling you down. It is the shape of space-time itself. Mass warps the fabric of space and time around it, and what we call gravity is simply objects following the curves in that fabric, like a marble rolling along a bent rubber sheet. The Earth doesn't orbit the sun because the sun is pulling it. It orbits because the sun has bent the space-time around it, and the Earth is following that curve. That is it. That is gravity. Now here is the part they leave out of the history books. After that breakthrough thought in 1907, Einstein spent 8 years trying to turn the idea into mathematics. 8 years of wrong turns, dead ends, and near complete despair. In 1912, he wrote to a colleague, "Never before in my life have I toiled anywhere near as much." He needed a type of mathematics he didn't even know. A friend, Marcel Grossman, introduced him to tensor calculus. Another friend, Michel Biseau, helped him spot errors. Max Planck, one of the most respected physicists alive, told Einstein in 1913 to give up. "You will not succeed," he said, "and even if you succeed, no one will believe you." Einstein kept going. By September 1915, he was in crisis. He wrote to an astronomer friend that he'd found a logical contradiction in his own theory. He was stuck. He couldn't solve it himself. His mind, he said, was too set in a deep rut. Then, in one of the most dramatic months in the history of science, everything changed. In November 1915, Einstein submitted 4 papers to the Royal Prussian Academy of Sciences, 1 per week. He was in a race against David Hilbert, one of the greatest mathematicians of the century, who was working on the same problem from a different angle. In the 3rd paper, Einstein used his new equations to calculate the orbit of Mercury. A tiny discrepancy that had puzzled astronomers for 100 years, and that Newton's equations could never fully explain. His new theory predicted it exactly. He later wrote, "Imagine my joy." I was beside myself for several days in joyous excitement, and on the 25th of November, 1915, Einstein presented the final version of the general theory of relativity to the Academy, a theory that said, space-time is not a fixed stage on which events play out. It is the event. It bends, it curves, it responds to matter and energy. And that curvature, that dynamic geometry, is what we experience as gravity. The day after his final lecture, Einstein wrote that only one colleague had truly understood the theory. That colleague was Hilbert. 4 years later, in 1919, British astronomer Arthur Eddington observed a solar eclipse and measured whether stars near the sun appeared to shift position, which general relativity predicted they would, because the sun's mass bends the space-time around it, bending the path of light along with it. Exactly as Einstein predicted, the next day, newspapers around the world announced that Newton had been overthrown. Einstein became the most famous scientist on the planet overnight. General relativity has now been tested for over a century. It predicted black holes, confirmed. It predicted gravitational waves, confirmed in 2015, exactly 100 years after the theory was published. Every single prediction it has ever made has been verified. Physicist Sean Carroll calls it the most beautiful physical theory ever invented. But Einstein himself never thought it was finished. He spent the rest of his life searching for a unified field theory, something that would merge gravity with electromagnetism and eventually with quantum mechanics. He never found it. That quest remains unfinished today. In Einstein's own words, it appears difficult to peek into the cards of the Lord God. The theory he finished in 1915 still stands. The theory he spent 30 more years chasing, the one that would explain everything, still eludes us. Every physicist working on quantum gravity today is still climbing the mountain Einstein pointed at. We're not there yet, but we're climbing. What Einstein did between 1907 and 1915 wasn't just solve a physics problem. He demonstrated that the universe is stranger, deeper, and more beautiful than anyone had imagined. That a single human mind with enough determination, enough creativity, and enough willingness to fail can pull back the curtain on reality itself. If this kind of story keeps you up at night, you are in the right place. Subscribe and tell me in the comments, do you think anyone will ever finish what Einstein started? Because I genuinely don't know. And I think that is the most exciting thing in science right now.